Okay. Hi, everybody. This is Christian from Washington Middle School Flagship. I'm glad you're all here. Today, we're going to be talking about all kinds of fun science stuff. We're going to be focusing on how to create carbon dioxide, because there's a lot of really cool chemistry and science that we can do with carbon dioxide from stuff that are already in our kitchen. So we're going to be focusing on that today. So we'll wait a few minutes to see if more people show up. But while we do that, I have a couple questions and things to ask. So first of all, if you are a middle schooler coming to watch this, I would ask that you please type your first initial, last name, and school that you're from into the chat. That way we know who's watching. And then secondly, I want you to think about it for a little bit on how you know to make carbon dioxide, maybe what carbon dioxide is. Maybe you don't even know what that is, and that's okay. We'll talk about that. So give it some thought, what you think carbon dioxide is, and we'll wait for a few more people to show up as we get started. So in front of us, while you're thinking about this, you can start setting up your own experiments at home. And the stuff that we're going to need today are a Ziploc baggie, and I'll start putting this stuff in front of our close-up camera. Hopefully you can see all of this. Okay, so a Ziploc baggie, some food coloring, some cooking oil, some kind of clear container. If you want to keep this is going to be for our lava lamp. So if you want to keep your lava lamp, a sealed container makes it so it's not going to make a mess all over the place. Some Alka-Seltzer, and this is to help create our bubbles. And then some water as well. And we'll be going over a couple different things that we'll be doing with some of these ingredients. So again, in the meantime, start gathering your stuff. And start thinking about what carbon dioxide is and where it comes from, how it's used in the real world and in science and all kinds of stuff like that. So if you have any questions, feel free. You can always ask them in chat, and I'm happy to answer them. I have my phone here so I can see the comments in real time. So keep an eye on that. Ask your questions away. And I'll give you guys a few minutes to kind of start gathering your materials and getting things ready. Just a reminder, we will be doing the science demo live stream every week on Friday at 3:30. So on the Google Classroom, you can always tune into go to the Google Classroom, and it'll have what we're doing that week, and we will have ingredients lists for the upcoming activities. Oh, hi Tootie, glad you could make it. So as we get going, again, this are all the goal of all of these experiments are going to be science you can do at home on your own from hopefully stuff you already have in your cabinets. There's a lot of really cool science we can do with materials already found in your kitchen or bathroom. So we'll be really focusing on kitchen science, as I like to call it. So a couple ways that we can start making carbon dioxide that are really common that you've probably done at home, and I'll scoot over here so I'm not being blocked by that close-up camera, are the really most simple way is just mixing an acid and a base. So things that are acids that you might find in your home are things like lemon juice, apple cider vinegar, regular vinegar, anything citrus, so fruits, are all have acid in them. And in fruits, you might already know the kind of acid in there, and that is citric acid, which they actually sell just as a powder. So we have some citric acid, and we'll be looking into that today as well. So things that are bases that you can find in your home are things like bleach, and a lot of cleaning supplies are basic. So if we think about acids, we think of things like fruits, which are sour, right? So that flavor, that sour flavor, is actually an acid that makes that flavor. Bases are things like soaps and bleach and things like that, common cleaning materials. And when you mix an acid and a base together, you create a new chemical. And that's what chemistry is just creating something new from two other things when they react. So, in order to make this work, we're going to be combining stuff to make new things. So I think we're first going to, and again, if you want to get your materials ready, now's your time to do that. Baking soda, vinegar, water, glass containers, or just your resealable containers work well. And then we'll be making our science experiments from these things. So if you don't have those ready yet, now's your chance. Go do that. And come back. You can always rewatch this. We'll be posting this on our YouTube channel, so you can always come back and redo these experiments on your own time as well. So, I think what we're going to do is just start with a very simple, let me grab a piece of glassware to show you guys. And I'm sure you've seen all of this before, at least this part. And it's just the mixture of baking soda and vinegar. So what happens when we mix baking soda and vinegar? So first we'll show you, and then we'll talk about the chemistry behind it. So there's our vinegar. We don't need much. You can see it's just kind of, I'll tilt this up a little bit. So there's our vinegar in our container. And then our baking soda, if we just add some baking soda, it starts to fizz, right? So that fizzing is the rapid release of carbon dioxide. And if you listen closely, you can hear it fizzing as well as seeing it. So what's happening is we'll go over the science behind that. So, bam, I came prepared. So I'm going to step a little bit closer so we can see this. So all that we just did, we did all of this complicated chemistry, and you've already known this complicated chemistry for a while now. We mixed baking soda, which is sodium bicarbonate, which is this chemical structure. We see some oxygens and hydrogens, some carbons, and then some more oxygen. And we see that there's this negative sign on this oxygen, and it's combined with a sodium. So this is called sodium bicarbonate. Bi means two, and then the carbonate word is coming from these oxygens bound to a carbon. So sodium, which is here, bicarbonate. So that's baking soda. And then we mix it with acetic acid, which is just vinegar. So acetic acid is the fancy scientific name for vinegar. And again, we see a similar structure where we have oxygen and hydrogens. We have oxygen linked to carbon, and then carbon linked to carbon, and then this carbon has 3 hydrogens as well. So when you mix these three, sodium bicarbonate, which is baking soda, and acetic acid, which is vinegar, we get sodium acetate, which is one of the chemicals left over from mixing these two things. And we can see that it actually is this chemical, our acetic acid, mixing with the sodium from our sodium bicarbonate, and it pulls that hydrogen off. You see, this hydrogen gets pulled off, so it's not there anymore, and it gets replaced by sodium. And that hydrogen actually moves over to this negative oxygen that we had right here. So now, that negative oxygen, it creates this, what's called an intermediate step, which is really just a fancy term for in between. Oh, and I realize I might be out of frame, so I'm going to step to the side this way in hopes that you guys can see this better. So, just recapping in case you missed what I was maybe pointing at, sodium bicarbonate mixes with acetic acid to create sodium acetate, and then this intermediate step that has oxygen and hydrogen all combined together, and then that kind of breaks apart. It's not very stable. And when that breaks apart, we get H2O, which you know is water, and carbon dioxide. which is CO2. So that's how we're able to make those bubbles, is because it's producing carbon dioxide bubbles when we mix these two things together. So one really cool thing about this is it's also creating its own water. So there's actually more water in that container than when we started. Even though we added some vinegar, but these two things combined made extra water. It made carbon dioxide bubbles, and then it made this sodium acetate. And we'll talk about more of that sodium acetate later on, because I have another cool experiment to show you. But in the meantime, so again, if you were from a middle school, just as a recap, please write your first initial, last name, and the school you're from. That way we know who's tuning in. And again, you can see it kind of stopped fizzing. But if we add a little bit more baking soda, it's going to start back up. So that baking soda is still reacting with the leftover vinegar. And it's creating more of that carbon dioxide gas like we talked about before. So now, what we're going to do is talk about another way to create carbon dioxide. And this way is a little bit more, and don't forget, we will come back to that sodium acetate that we talked about. So, what we're going to do is we're going to take some warm water. So I heated this water up, and I'll do this in front of the close-up cam too. We're going to take this warm water and pour it into this empty container. And then we're going to add a little bit of sugar. And I'll talk about why we added sugar in a little bit. But what we're doing here is we're going to be adding some yeast. So yeast is what makes bread rise. And it's what makes... and it makes carbon dioxide gas, just like our baking soda and vinegar. It creates carbon dioxide gas, and that's how we get those little tiny pockets of air inside of bread. It's because this yeast rises, and the reason I added sugar is because yeast eats sugar to make carbon dioxide. It's a little bit more complicated of a chemical reaction, but it still is a chemical reaction. And you know what? So I'm going to let that go. And in order to prove that this is creating carbon dioxide, we're going to put this little balloon on top. So right now you can see the balloon's empty. But as this continues on, and I'll leave this in front of the close-up camera, we'll be able to see that balloon get inflated. And I'm actually going to quickly move our close-up camera to the other side. That way I'm not getting blocked so much. Okay. So we'll let that go. This takes some time. That yeast is dry and it needs to kind of wake up and remember what it's doing. So as that happens, we'll move on to the next thing. And the next thing I think we're going to do is we're going to look at creating it. So this is going to be one of the steps you can follow along with. So if you take your plastic baggie and add a little bit of baking soda. You don't need a lot, maybe like a teaspoon's worth. And we're going to add that into one side. So you can see it's just a little bit of baking powder, or baking soda, I should say, into one side. And then we're going to very carefully into the other side. We're going to fold it in half. So we have it like this, right? So we have one corner and the other corner, they're completely separated. And then on the other side, we're going to add a little bit of our baking soda, our vinegar. And this is kind of tricky, so maybe it's helpful to pour it into a smaller container first, and then pour it. So now you can see we have a little bit of baking soda in one corner, and a little bit we have a little bit of baking soda in one corner and a little bit of vinegar in another. And then what we want to do is, without combining them, we want to zip this baggie closed. So there's no air, or very little air. So you can see there's very little air in here. And then what we're going to do is we're going to just combine the two. And you can see it's going to create that fizzy bubbliness. And you can see that the bag is starting to fill up with carbon dioxide. So remember, this was an empty bag, and now we now have a bag full of carbon dioxide. And this bag doesn't have the best seal. It's kind of leaking out. So we're going to do this again. So this is one thing you can do at home to follow along. And then I'm going to do this again, but instead of using vinegar, I'm going to use our citric acid. Because our citric acid comes as a powder. It looks like I grabbed the unopened one. Do I have the open one? Don't think I do. Okay. So I'm just going to open this. I'm going to get a knife to open this. So just to prove to you this really is a powder, I'm going to pour it in here. So we now have our powder in here. Oops. Spilled a little. Science. It's not really science if it's not messy, right? So here we have a little bit of powder of our citric acid. And then I'm going to add our sodium bicarbonate, or baking soda. And now we have an acid and a base, but they're both powder form. So they're not actually doing anything right now. So what we're going to do is, so first of all, in order to have a chemical reaction happen, you usually need to be in water, or what chemists call it is an aqueous solution. So you need to have an aqueous solution, so you need to have your chemical reaction happen in water. So what I'm going to do is I'm going to take a little bit of our water, and just like before, I'm going to pour it into one side so they're not mixing yet. And then I'm also going to add this pH indicator. So this is called bromothymol blue, and all this does is talk about pH. And it shows us what our pH is. So right now, it's really blue. You can see how it's really, really blue. So pH indicators show the pH. So acids have a low pH, and bases have a high pH. So what this is going to tell us is what pH our final solution is. Right now, since it's added to water, it's neutral, which is about 7. So our vinegar here is pH around 3 to 4, and mixed into water, because in order to get a pH, you need to have water around. Mixed into water, our baking soda is around pH 10. So when we mix these two together, so right now, what we should see is when we mix these together, we should see a chemical change. You see it turns yellow. And it's really filling up with air, because I had a little bit more stuff. And you can see it's almost completely full, and it might even pop. And you can't feel this, but it is really cold. So when this happened, it created what's called an endo-thermic reaction. So I'll bring this up to the bigger camera too, so you can see it a little bit better. So we can see it's completely full and actually about to pop. So I'm going to set this down and let this pop, and hopefully it's loud enough for you guys to see it. Or hear it, I mean. So endothermic, endo means in. So it's an endothermic reaction. It is cold because it's drawing in energy. The opposite of that is an exothermic reaction, where it pushes energy out. Exo means out. So those feel hot. So this is endo because it's cold. Exo is hot. And we saw that chemical, or that pH change, because we saw the pH indicator go from blue to yellow, and this indicator, specifically bromothymol blue, goes to yellow in the presence of acids. So that's why we saw that happen. And I don't know if you can still hear it. It's still kind of fizzing. But we'll let that continue. And we can see nothing quite. I can tell you that there's a little bit of stuff in here, but not quite much. But we'll let that continue and let that breathe, that balloon, as we continue on. So now our next step is we're going to be talking about a very similar chemical reaction than what we just did, and we're going to be looking at Alka-Seltzer. So Alka-Seltzer is exactly what we just did. It is citric acid combined with sodium bicarbonate and aspirin. So people will usually put these in a glass of water and let it fizz and bubble because it's an acid and a base combining, so it creates that CO2, that carbon dioxide gas. So it's going to create that CO2 into the drink, and it's also going to release that aspirin to help digestion and help with like a headache or something like that. It's a pain reliever. But we're not really interested in the aspirin part. We're just interested in the two other parts, the acid and the base. So what we're going to do now is we're going to create our lava lamp. That's our next experiment we're going to do. So take your container, and what you want to do is, I'm going to need some more water. We're going to fill this up about 1/3. You don't have to be super precise. But about 1/3 of the way. In fact, I'm going to get a little bit more. A third to a quarter. So once we've filled it up 1/3 of the way, and I set down my... It's okay, I have another one. I don't know where I put my first Alka-Seltzer. So, we're going to take 1/3 of the way, and then we're going to add some food coloring, because this is going to be the color of our lava lamp. So I'm going to choose green, because green's my favorite color. Actually, you know what? We're going to do red, because that's like lava. It sounds more accurate, right? More scientific. But you can choose whatever color you want. So there's my color. So this is going to be the lava part of our lava lamp. And then, make sure that color's mixed in really well. And then what we're going to do is we're going to top this off with our cooking oil. So I'm using canola oil, but you can use really anything. It does not matter as long as it's an oil. So we're going to fill this most of the rest of the way up. We don't want to go too full. Give it a little bit of room. So now, I'll move this over to our close-up cam. We can see what this looks like. We see this layer difference, right? Because oil and water don't mix together. They have different what's called polarities. So since they have different polarities, they don't like to mix because the saying is likes dissolve likes. So these are so different that they don't want to mix together. So what we're going to do now is we're going to mix, or we're going to add a little bit of our Alka-Seltzer to the bottom here, and it's going to start to bubble and fizz but only when it hits the water. It won't bubble when it's around oil because remember, most chemistry happens in water. So once we add a little bit of our Alka-Seltzer, it's going to drop to the bottom and start reacting with that water, and it's going to create that carbon dioxide bubbles just like our baggie did, and it's going to start bubbling. So there goes the bubbles, and the bubbles are going to rise up to the top and carry some of that colored water. So we can add a little bit more to make it go faster. And I have more Alka-Seltzer if we need it. So you can see it starts to bubble on its own and really create that cool vortex effect where it's bringing that water up, and then once it reaches to the top, the carbon dioxide gets released out of the oil, and then it drops back down, so we get that. I'm going to move the direction of the camera so you can maybe see this a little better. Oh, you can see some of the carbon dioxide some of the Alka-Seltzer got carried to the top. that'll happen sometimes. But we can continue to do this. I'm going to grab some more Alka-Seltzer. Can't believe I lost the other tablet. Oh well. Put it down somewhere, who knows where. You guys might have seen it. But whenever you want to get this going again, all you have to do is just add some more Alka-Seltzer. So it'll start to bubble and fizz up and make that whole cycle go again. And actually, you know, something I've never tested that we're going to test right now because it's science. Oh, here's the other Alka-Seltzer. Is we're going to combine... I'm going to get a piece of paper to do this. We're going to combine some baking soda and citric acid as a powder, like we did with our baggie, and drop it in here. I have no idea what's going to happen. It might not react, but it might, so who knows? It's the fun of science, is just testing things out. So I'm just going to mix these two powders together so they're all kind of combined. So they're not reacting yet because there's no water. But then once I dump it in here, hopefully it reacts once it hits that water and we see that reaction. Oh, it is kind of working. Awesome. So the Alka-Seltzer works a little bit better because it is that compressed tablet, so it's able to sink to the bottom all the way. So another thing we can do is we can attach another balloon to the top of this and show that, hey, this is happening way faster than the yeast. There we go. It's going. Hopefully I got a good seal on that. So it'll just continue to fill that up. And this balloon is filled entirely with carbon dioxide right now. There's nothing else going into it except for what's released by our tablets and this citric acid and baking soda combination. So again, mixing an acid and a base together. I'll tilt this up so maybe the close-up camera can see that balloon. Yeah, there we go. Good. So it's continuing to grow and get bigger and bigger and bigger. And if I didn't get a good seal on it, it will, it might pop off. But I think we're doing okay. So we can see that this is way, way faster than our yeast. And I think actually I might have used some old, there's a little bit, I think I used it pre-open package, and I think that yeast might be dead. So what I'm going to do, add a little bit more sugar so the yeast has something to eat. I'm going to open a new packet of this that is hopefully not dead. And we want our water to be a little bit warm because it kind of wakes the yeast up a little bit better. It smells very yeasty. We'll put our balloon back on it. And hopefully that starts to... So just so you guys can see where we're at, there's basically no air in this balloon right now. So hopefully in a few minutes we start to see that increase. And you can see this balloon's getting even bigger and bigger. So one thing that's really cool about the yeast product, it's a lot slower, but it will continue to happen because as long as there's food, because yeast is a living organism, and it's going to continue to eat that sugar, and as it eats more, it produces more carbon dioxide. So as it produces more and more, that's why when you're making, if you've ever made bread at home, you have to let it rise, and you have to let it sit on the counter for a while as it continues to get bigger and bigger, and that can take hours or sometimes days. Uh-oh. And my big camera just died, so I was afraid this might have happened. So what we're going to do is we're going to just move our close-up cam over. Unfortunately, my big camera has a low battery life. We'll try that. Let's see how that works. I need my tape again. Let's see how we'll pull this up. Give me just one moment to get everything reestablished. We'll make this bigger. Center it. Move it over here. Sorry for the technical error. We're just going to move it right up top here. There we go. Okay. So, yeah, that works. So we can see that this balloon keeps growing bigger and bigger and bigger as we continue to add CO2, but you can also see it's starting to slow down a lot. So because this is a chemical reaction versus so this is straight chemicals, well this is as well, but this is more of a biology reaction, which is a lot more complicated. This is going to go a lot slower, but it will get there. This is going to go a lot faster, but end a lot sooner. So we'll just set those off to the side here for now. And again, you can always add more stuff to this, more baking soda and citric acid, or that Alka-Seltzer tablets. It's all the same thing. So as a little demonstration of how quickly this releases carbon dioxide, we're going to take a few drops of water into this little tiny beaker. And we do this in a small container so we can really see the reaction. And we're going to take just an itsy bitsy tiny little bit, and I'm going to come up closer so you can see this a little bit better. So you can see we have this is called an Eppendorf tube, but it's just a little, it snaps shut. So what we're going to do is put a little bit of our Alka-Seltzer in here, quickly snap it shut, give it a few shakes so it can, and then listen. Oh, maybe this one doesn't have a good seal. Woo! There we go. So that's how powerful this can be, because it produces a whole lot of gas really, really quickly. That gas has to go somewhere, and since I put it in a tight sealing container, it couldn't go anywhere, and it kept building that pressure and pressure until it had enough force to pop that lid off. So we can do that one more time just because I think it's super exciting. Oh geez. There's still quite a bit of stuff in there. I wasn't expecting that. Oh, that sprayed all over my living room. That's awesome. Oh, cool pop. Yeah, right? So we'll set this off to the side, and I think it's going to pop one more time, too. So because of this, remember this is a really, really small container. So we have, see, there we go. So just imagine this on a bigger scale. We have to be really careful with this stuff because it can really cause some damage if we're not careful. So because of that, if you're making this at home, your lava lamp, never, ever, ever put the lid on it until it's done bubbling. Because if you do that, it could explode and cause a lot of damage. So you want to be really, really careful. And that's why we use balloons to show this, because we get to see the expansion of it without any explosions. So one thing that's really cool is this is now a balloon full of carbon dioxide. And this is pretty much done, so I'm going to take this off and close this. And just like that, we've collected our own container of pure carbon dioxide. So carbon dioxide is you hear a lot about it, talking about like global warming and stuff like that. It's all over the place. You've probably heard of it 1,000 places. Some other places we see carbon dioxide generated is burning things. So like fires create carbon dioxide, as well as running cars, because it's just another way to burn things. So if we have some extra time, we might talk about fire a little bit. But right now, we'll just continue on to this. So here's our balloon full of carbon dioxide. Just like we had our baggie full of carbon dioxide, made in a different way. So there's lots of ways that carbon dioxide enters our world. So if you remember back, this next experiment is not talking about carbon dioxide, but it's talking about, and hopefully we've cooled down enough, talking about the mixture of sodium bicarbonate, baking soda, and vinegar, acetic acid. So if you remember, we had this other chemical compound called sodium acetate that it also produced. So sodium acetate is really cool because it's really, really, really soluble in water, which means you can dissolve a whole bunch of it. So if you've ever made lemonade or something and put sugar into your lemonade, it dissolved, right? You had to stir maybe because it was cold. So when you're doing that, you're dissolving something into a solution. So what I did is I took a bottle of sodium acetate and added it to a little bit of water, but since it dissolves so easily, I added a whole bunch. And then what I did is I heated it up to add even more, because when temperature increases, the amount of stuff you can dissolve into water increases. So with really hot water, I'm able to add even more to it. And then it stays dissolved once it cools down. So what I did earlier is I heated this back up, and hopefully, fingers crossed, it's cooled down enough. Because one thing that's really nifty about this sodium acetate is it can dissolve really well in water, but if there's anything that's introduced to its surroundings, that it can start to form a crystal, it's going to do that right away. So what I'm going to do, actually, I'm going to bring this a little bit closer to the camera. I have to be careful because I want you guys to really see this. So here I have, in fact, I'm going to get a little bit more of our crystal. I have this stick with some sodium acetate crystal on it. Oh, it's already started. So it's going from a liquid to a solid really, really fast. And I wish we had our close-up camera. So you saw just a second ago, this was a clear liquid. And if you look on the side, it's still doing it. Let me down the container. So that liquid is turning to a solid very quickly. And I might show this again next time so we can get a better view of it. But we just went from a liquid to a solid. And that's because we introduced what's called a point of nucleation, which is just a fancy term. Oh, let me bring the camera back up. Which is just a fancy term for a spot for crystals to form. So once we have that spot for crystals to form, they're going to start to branch out and create more crystals and more crystals. And one thing that's really, really cool about this is it's really hot. I know I'm touching it right now, but I can't hold on to it for very long. It's that hot. So this is an example of our exo-thermic reaction. So remember, this baggie got cold when we did our chemical reaction? That was an endothermic. This one is an exothermic, which means it got hot when it started to form those crystals. So it started putting off energy. So the way we undo this is we just heat it back up. So I will then go and boil this, and all those crystals will dissolve again. And then once those crystals are dissolved, then we have a clear liquid. And once it cools down, it will then reform a solid once we provide that point of nucleation or spot for crystals to form. And that's what this little stick was for. It can also form just by agitating it. That's why I was a little worried about carrying it, because if you shake it, that can also provide a spot for crystals to form when things get moved around really, really quickly. So that's where, and this is it's getting even hotter as I talk. So that chemical reaction is still happening. It's still forming those crystals. You can make this at home fairly easily just by mixing vinegar and baking soda and then boiling off the extra water. But because you have to boil it and it takes some time, I recommend definitely making sure you have a parent to help. And I will maybe include on the Google Classroom instructions on how to do this at home. There's also one other step. Sometimes the crystals, if you heat it up too quickly as you're boiling it, the compound will start to turn a little yellow. So what you can do is you can just rinse that away with alcohol, high percentage alcohol, like rubbing alcohol, like 70% or higher. The higher the better, because the more water, the more you'll dissolve your crystals, and you don't want that. But like I said, I'll post a link on how to make this at home, and it's a lot of fun. But it does take a few hours. It's a great afternoon experiment because you do have to boil it for so long. So now, if you have any questions, please feel free to ask. I'm happy to answer anything. Oh, but in the meantime, if you look, our yeast is starting to go. It looks like I was just dealing with dead yeast before. And you can see even up in here, we're getting this layer of bubbles and the carbon dioxide gas from the top. So again, we're creating carbon dioxide gas from yeast eating sugar. And then it's producing, producing that carbon dioxide gas. So lots of ways in nature to create carbon dioxide gas. We talked about baking soda and vinegar. We talked about citric acid and sodium bicarbonate. All kinds of really cool stuff and fun ways to make a lava lamp. So again, if you have any questions, please reach out. You can always email me at my school email. You can find that on the Google Classroom as well. Again, if you have any questions, I'm happy to answer them right now. Thank you so much for joining us. It's been a blast. Next week, same time, same place, you can come back to this same link and we'll be hosting a new science experiment to do at home. Next week, we're going to be looking at some of my favorite chemical reactions, as well as one that, and this is one of my favorites, it's called an iodine clock. And hopefully it's stuff being made with stuff you already have at home. If not, hopefully the ingredients are at the store and not sold out. So, check the Google Classroom, or reach out to your YDC with any questions about how to join us. And there's going to be a lot of fun experiments that we're going to be doing in the future. So keep an eye out for those, and I hope to see you next time. And again, feel free to ask questions. I'll hang out for a question time right now if anybody has anything they'd like to ask. And thank you so much.